Hey everyone, in this video we'll learn how to build and construct confidence intervals in R. So let's begin. So I have the R script all set, so I'm just going to run the first batch. Yeah. All right, so we're going to go over two examples. One where the population standard deviation is known, that is we know the sigma, and another example where sigma is unknown. So when we know sigma, we can actually construct the margin of error using the normal distribution. So we'll do that in the first example. When we don't know sigma and we use the sample standard deviation S instead, in that case, we don't use the normal distribution, but rather we use the t distribution to construct the margin of error. So we'll do that in the second example. So I'll go over one example in each case, and I've also provided a couple of other examples here for you to try out, and I'll provide answers to the same here. So let's begin with the first question. Now, the standard deviation of the weights of newborn elephants is known to be approximately 15 pounds. We wish to construct a 95% confidence interval for the mean weight of newborn elephant calves. 50 newborn elephants are weighed, and the sample mean is given, and the sample standard deviation is given to us. And we want to construct a 95% confidence interval for the mean weight of newborn elephant calves. Now, we know the population standard deviation because that's given to us, and it's about 15 pounds. We know the sample mean. So we have actually, and we also know the sample size, which is 15 newborn elephants. So as long as we know X bar, sigma, and N, we can construct our confidence interval. So let's go ahead and identify the key things that we need. So the sample mean here is 244. The population standard deviation is given to be 15. So I'll identify that. The sample size is 50 newborn elephants. So we'll put that down. We want to construct a 95% confidence interval. So the confidence level is 0.95. And therefore, alpha is 1 minus the confidence level. So alpha is going to be 0.05. So we can check if that is indeed the case. So if I put in alpha, alpha is 0.05. Good. Now the next thing is we're going to find out the critical value. So the critical value here is actually nothing but z underscore alpha by 2. Now, this z alpha by 2 is actually the particular point in the normal distribution such that the area to the right of this point is equal to alpha by 2. So if we put down a normal standard normal distribution, so let me see if I can pull up my yeah. So give me a second. Let me show you my there we go. So we want to find z alpha by 2 such that area to the right of that point is equal to alpha by 2. So if alpha is equal to 0.05, alpha by 2 is equal to 0.025. So if we know the area to the right of this point is 0.025, then we can easily find the area to the left of this point, and that will be 0.975. And we can plug in this area into our Q norm function in R to figure out what z alpha by 2 would be. So let's do that. Going back to my R screen. So the critical value here. But before that, let me just get alpha by 2, which is nothing but alpha divided by 2. Now to get the critical value, I'm going to call it, so this z alpha by 2 is generally referred to as critical value. It will make more sense when we do hypothesis testing later. So this is actually nothing but Q norm, where the area is 1 minus alpha. So this is actually, sorry, give me a second. So Q norm, the probability, the area to the left is 1 minus alpha by 2. And I'm looking at a standard normal distribution. So this is my critical value. So let's see what the critical value is, and it's 1.9599. And this is, you can cross-check by using the applet. You can also check out the Excel links. And this is the answer we get in both. Now, once we know that the margin of error is nothing but the Z critical value multiplied by sigma by square root of n. So which is exactly what this is doing. So let me compute the error. And the error is 4.1577. Now, once you know the margin of error, the first way to find the lower limit of the confidence interval is just the sample mean minus error. And the upper limit is given by sample mean plus error. And let's see what the lower limit is. It's about 239.84 pounds. Upper limit is 248.157 pounds. And that is how you construct the 95% confidence interval in this case. Now, this particular example has a couple more variations where we increase the sample size. So I encourage you to give it a shot and try this out. We'll now go over the second example where the population standard deviation is unknown. So here we're now going to actually use a t-distribution. So let's read the question. A hospital is trying to cut down on emergency room wait times. It's interested in the amount of time patients must wait before being called back to being examined. An investigation committee randomly surveyed 70 patients. Sample mean was 1.5 hours and a sample standard deviation of 0.5 hours. So let's construct a 95% confidence interval for the average ER wait time. Okay. So let's identify the key things we'll need. We'll need X bar, which is the point estimate. And to construct the margin of error, we'll need our t-stat. And for t-stat, we need alpha values and we need the degree of freedom values. So for that, first let's identify all the information that we need. The sample mean is 1.5. Then the sample standard deviation is 0.5. The sample size is given to be 70 patients. And the degree of freedom is generally n-1, so that will be 69. The confidence level is we want a 95% interval, so it will be 0.95. Alpha is going to be 1 minus confidence, so that will be 0.05. And let me just construct an alpha by 2, which is nothing but alpha divided by 2. Now, let's go and find the t critical value. So this is going to be t alpha by 2 with n-1 degrees of freedom. So here again, it's going to be very similar to how we did it for the previous case. So to show you a visual example of how this would look like. So if I draw the t distribution, and if I draw a t distribution with n-1 degrees of freedom, I have the point t alpha by 2 is such that area to the right of the point is alpha by 2. And therefore, area to the left of that point is 1 minus alpha by 2. So we can use the inverse function here. And the function is just q followed by t. And then you'll put the probability 1 minus alpha by 2, 0 mean and 1 standard deviation. And that will give me the value of t alpha by 2. So going back to R. So I'm going to call this the t critical value. So this is just qt, where the probability is given by 1 minus alpha by 2. The second argument is degrees of freedom, which we have defined as DOF. And it's enough if we just fill in these first two arguments. We don't need to worry about the others. So let me run this. And let's look at the t critical value. The t critical value is 1.9949. And this also matches what we saw in Excel earlier. Now, once you know the critical value, the margin of error is just given by this critical value into sample standard deviation by the square root of n, which is what I've put into this formula here. So given that we've already defined sample SD, n, and the others, let me compute the error. Turns out the error is about 0.119 hours. So let's get the lower limit. It's just the sample mean minus error. Upper limit is sample mean plus error. So if I look at the lower limit, it's 1.38 and the upper limit is 1.619. So that's the confidence interval for this particular question. So I have another example here, which I encourage you to try out, and I'll put in the answers here. So good luck practicing.